So the third part of this session looks at EPC, or Evolved Packet Core. Okay. And as we've already mentioned, LTE is an end-to-end IP technology. So all the way from UE to the internet, the layer 3 protocol is IP, and we have routers within the core networks to route the packets to towards the external networks. We've also talked about some new IP core network elements, 4 new network elements that were introduced: the MME, the serving gateway, the packet gateway, and the PCRF. And all of these network elements are based on IP. So what is the function of the EPC? So essentially the EPC, the EUTRAN, the main function of the EUTRAN is to get the user packets and deliver them to the EPC, or the Evolved Packet Core. And the Evolved Packet Core then gets the data to the external network. So all the user data has to go through the EPC. There's no way user packets can go from the UE to an external network without going through the EPC. Even if you're, for example, if you're roaming and you are in another part of the world and your packets have to come to your home network, they'll be passing through the EPC in your home network. So what are the important characteristics or functions of the EPC? Basically, all of the functions that were previously provided by the circuit switch and packet switch domain in a 3G network have to be now provided by the EPC. Okay, so you can see that in the previous 2G technologies we had a circuit switch core, and then we had a packet switch core that was introduced in GPRS. Both of these core network elements were used in 3G, and now we have combined them into a single core network called the EPC. So as we mentioned earlier, there are 4 important network elements that make up the EPC, and we'll have a look at each one of them in turn. So if you look at it from a high level, what are the important functions of the EPC? Well, remember, the 4G is going to coexist with previous technologies. So it's going to coexist with CDMA 2000 based networks. It's going to coexist with wideband CDMA networks, and it will coexist with all our legacy 2G and 3G networks. So the EPC has to also communicate with the previous technologies to enable handovers and also provide continuity of service for users. Okay, and we also saw earlier how by the use of the MME we are able to separate the control plane as well as the bearer plane functionality. When we compare it to the previous core networks, the EPC has got better quality of service. So we have per session, per subscriber quality of service with advanced centralized policy management and distributed enforcement. So that's why we have the PCRF functionality that's now been built into the core network. So we can provide better quality of service for UEs compared to previous technologies. And the other important function, okay, with any mobile operator, they have to recoup the expenses. So all of the billing data is all generated in the EPC. So both the serving gateway as well as the packet gateway are involved in the generation of billing information, so we can charge users for the services that they have used on a mobile network. So again, if we go back to this diagram which we saw earlier, okay, so we have two planes, the control plane and the data plane. The data plane shown in red on this slide essentially goes from the eNode B through the serving gateway, through the packet gateway to the external network. So all the packets that carry user data will go along the red route there, whereas all the control messages that have to go are shown in the blue dotted line, okay, and most of them will end up going through the MME. Okay, so there are a few control messages that will also go between the PCRF and the packet gateways. The PCRF is where all aspects of quality of service are kept, and these policies are used to enforce the quality of service aspects in the EPC network. Okay, so let's have a look at the MME. MME, which stands for Mobility Management Entity. The main function of the MME is that it works in the control plane. So the main aspect of it is to control mobility management as well as the setting up of sessions. User data sessions will also be performed by the MME. So the MME has to communicate with the eNode B, so all the control messages, all the user requests will come in through the eNode B to the MME, and then the MME then communicates. I think it's given on the next slide. Okay, when a user request comes in to the network, it goes in from the UE to the eNode B, and from the eNode B the message goes to the MME. So one of the first things that we have to do, say you're a 4G user and you say, I want to make a call. Okay, you dial a number and you say press your green button. Okay, what your mobile will do is it will send a control message to the eNode B, and the eNode B will then forward that call request to the MME. Okay, the MME will then go to the database and extract information about you. Okay, how should I authenticate this user? How should we encrypt the data that the user is going to send? Okay, then in that time that you have pressed the green button and you're waiting for your call to come up, an authentication process takes place. So the MME will authenticate you. Are you really whom you claim to be? And once that authentication is done, the MME will also check, is this subscriber allowed to make this call? For example, in my phone I've made sure that all international calls are barred. Okay, so that I don't want to be able to be charged for an international call that I make from my mobile phone. So it will then go to the HSS database and check, is this subscriber allowed this service? Okay, because there's a list of allowed services which are stored in the database. And then if the subscriber is allowed that service, that's the next step where the MME will then go to the serving gateway and say, okay, let's establish a bearer between the eNode B and the serving gateway, and then between the serving gateway and the packet gateway, so that we can set up a pipe essentially for the UE packets to flow all the way from the UE to an external gateway. Okay, so many things from the time you press a number to dial, or from the time you say I want to go to this web page on your 4G phone, lots of things take place behind the network which a user is not aware of. Okay, and all of those control functionality is mostly handled by the MME. Okay, so exchange of control information, MME goes and queries the database, gets information about the UE. Okay, and in the GSM world we had something called triplets. I don't know if you remember them. Some of you may know that. There's each UE has 3 pieces of security information, and then in the 3G we have quintuplets. We had 5 pieces of security information, and now we'll go into security more detail in subsequent classes. So all you have to know at this stage is that some security information has to be extracted from the database, and that is used to authenticate the user. So MME is directly involved in this thing. Now all these processes take place without the UE knowing about it. Okay, remember there is information stored in your SIM card. Okay, the security information stored in your SIM card. So the MME sends some questions or some messages to the UE, and the UE responds to those messages based on information in the SIM card. But you as a user is not aware that these transactions are taking place. Okay, and based on the responses that the UE sends to the MME authenticates the UE. Okay, so if you look at the MME is connected to a number of network elements. Okay, so on slide 39. So what are the interfaces coming out of the MME? Okay, so the first and most important interface that comes out of the MME is the link to the eNode B, and that's one is called the S1 MME interface. Okay, the next interface is the S10 interface. Now remember, we talked about a pool of MMEs, or group of MMEs. So the interface between one MME and another MME is referred to as the S10 interface. Okay, so that is an interface to other MMEs. The third interface that you see there is called the S6A interface. Okay, the S6A interface is to the HSS. Okay, again, that's all control information. So whenever the user needs security information or service related information about a subscriber, that will be sent on the S6A interface. And then there's also the S11 interface to the serving gateway. Okay, and so this is where once a user is completely authenticated, the MME will tell the serving gateway, okay, it's time now to set up a bearer for this particular UE. Okay, so again, that's still control information, because remember, all the user data is on the red line. Okay, this is all happening in the blue dotted line. Then the next interface is, you also have something called EIR, Equipment Identity Register. Okay, so EIR is where the network keeps information about handsets. Okay, now remember, the handset and the SIM card are 2 different pieces of information. Okay, the SIM card is what you have in your authentication center or HSS. Okay, because that's about subscriber related, whereas the handset information is held in the EIR. Okay, so the S13 is the interface to the EIR. Sorry? Yeah, if there is a stolen handset, when you phone your operator and say, look, my phone has been stolen, the operator should go into the EIR database and change a setting to make sure that nobody else can use a handset on the network. Okay, so that's done in a database called the EIR database. Okay, so that's your S6A and S13 interfaces. And then you have there's another interface, X11 and X2 interface, X11 and X2 interface. Now this goes out to something called LRG. Now this is some of you who've done lawful interception gateway. Okay, and why do we need a lawful interception gateway? Sometimes the intelligence agencies, okay, in Australia there is ASIO, which does all the intelligence related. They want to be able to track a mobile user. Okay, they want to be able to find out what calls they're making, whom they're making it to, what data they're sending, which websites they're going to. So if ASIO goes to a mobile operator like Telstra, Optus, and tell them, look, we want to know every packet that is transmitted by such and such a user, then the MME has to inform the legal interception gateway that this target subscriber is making a call, and all the data that particular target subscriber transmits is stored in the lawful interception gateway, and intelligence agencies can access that data for whatever purposes that they need that data for. So that's why you have that interface, the X112 interface. Now, so just a quick recap. We're only going to look at the two important interfaces here. So the first interface is the S1 MME interface, which is the interface between eNode B and MME. So all the information that is needed to set up a user data session is transferred on this interface, and also security related information is also. So for example, all the authentication messages that the MME has to send to the UE will all go on. Another interface is the interface between the S6A interface. We've just selected two interfaces at random to describe them a little bit. So the S6A reference point. Okay, now there's two words. There's a word called interface and there's a word called reference point. Reference points are points that interfaces are well defined in standards, whereas reference points are not so well defined in the standards. So that's something to remember as well. So S6A enables data transfer between the database and the MME. Okay, just a quick recap of what we've done with MME. So the MME has to communicate with a number of entities. The MME the first and foremost important entity is the users. So messages related to mobility management, messages related to setting up a session or setting up a bearer for a user. All those messages have to go between the UE and the MME via the eNode B. And there are also messages between the eNode B and the MME. Okay, so when there are handovers from one eNode B to another eNode B, okay, the MME has to be updated to say, okay, this is the eNode B that is now handling this particular UE. Other messages are between MME and serving gateway. Okay, so this is where we have to set up, whenever we need to set up a bearer for a UE. These are referred to as tunnels because we use something called a tunneling protocol between the serving gateway and the SGW and the PGW. So that's why they call it as control of user plane tunnels. Then the MME has also got to go to the HSS and extract security related information and authentication related information, and also location management. The HLR has also got to keep information about where a user is located. Okay, and the MME has to also communicate with other MMEs for the purposes of handover and so forth. Okay, so this is a summary of what the MME does. And again, this is all from the Hallmark texts, Hallmark 2009 text, which is on this particular diagram is from the Hallmark 2009 text. So you can have a look at that if you need more information. Okay, as I said, this class is a pretty long one because we've got quite a lot of slides. Okay, next one is the serving gateway. So serving gateway, this is the serving gateway. Okay, what does it do? Well, it's one of the important entities on the user plane because all the user data that is has to travel between the eNode B and the external gateway has to go through the serving gateway. So it has to maintain the UE data path. Okay, on the next slide is some more detailed information. Okay, and I'm going to talk about these points shortly. Another important term that you will see is it says here serves as a local mobility anchor. for a UE. Okay, so when, for example, when a UE, imagine that you are moving and you're still having your call or you're still having your data session. Okay, you may be changing from one E node B to another E node B to another E node B and so forth. But during this time, your packets will all go to the same SGW, serving gateway. So that's why it's referred to as anchor point. So even though you may be, imagine a user is moving, maybe they're on a car and they're moving on a highway, you may be changing even 100 base stations, in a couple of minutes. But during all this time, even though you're changing these base stations, your packets are still coming to the same serving gateway, and that's why it's referred to as a local mobility anchor point. So all the UE packets will have to pass through this particular. Apart from that, the serving gateway also has some routing function that it performs. So incoming packets that are coming from an E node B have to be routed to the corresponding PGW, and similarly packets that are coming for the downlink direction from the packet gateway have to be routed to the correct E node B. So the routing function, routing and forwarding function, is also maintained by the serving gateway. These are the two important functions. Okay. There's a good question. Okay, why do we need two separate nodes, a serving gateway and a packet gateway? Okay, why can't we just have one node? Okay, that's a very good question. Some of it comes from the way the networks evolved. Okay, from the network evolution point of view, we had the SGSN and GGSN, and they separated them because when you are roaming, okay, you may be say you move from Sydney to Singapore and you make a data call there, and you're making a data call to your intranet in your home country. Say you work for IBM and you want to access some information from IBM in Sydney. Okay, your data packets are going to go through a base station in Singapore to a serving gateway in Singapore, and then it will come to the packet gateway in Australia. Okay, so that's for roaming traffic. Okay, now if you had only one node, that will be problematic. Okay, so that's why they separated these into two functions. Okay, so this is a diagram. If you look at this animation here, I don't know if you're able to see it. Look at this user. The user is moving from one base station to another base station, and in that process, the user data plane has got changed from the first E node B to the second E node B. So that's what this remains a local mobility anchor. Yeah.
So what determines which SGW is user sample?
Okay, that's all done at the beginning of a data session. At the time you make your call, the MME selects the serving gateway that is going to serve you. That based on the location of your base station, it selects the best serving gateway to serve you. Okay, once that SGW is initially assigned, you stay on that SGW until you end the call. Okay, only when the call is ended and you make a new call, you may be allocated a different SGW. Okay, so but at the time you initiate your call, you be allocated an SGW and you stay on that SGW until you end your call.
So regardless the E node B.
Regardless of the E node B, you could be changing E node Bs, but you'll be staying on the same SGW. Okay, so what are the interfaces for the SGW? Well, it's got four important interfaces. It's got to talk with the PGW, okay, and that's on the S5 interface. Now on that interface, you've got both control information as well as user information. Then you also have the S8 interface. Okay, now it says here visiting SGW to home PGW. Now this is for roaming users. So it's possible, as I said earlier, that the SGW and PGW are not in the same network. Okay, you could have the PGW could be an Optus PGW, and if you are roaming in Singapore, for example, and you're on the Singtel network, your SGW could be in Singapore. So the interface between those two, okay, it will be a visited SGW and a home PGW. That's for roaming traffic. Okay, and that's the S8 interface. Then you also have the S11 interface, which is an interface between the MME and the SGW. Okay, that's again used for the MME to control the SGW. In terms of the database, initially, when you initially make a call, when you roam into, say for example, this user that gets off the plane in Singapore and switches their mobile on, okay, the mobile will initially search for the home network, and if it cannot find the home network, then it has a list of roaming partners. So this interface, the S8 interface, will only come later on after the user is authenticated, and then they will go through the visited SGW to the home PGW. Okay, we move on. So a quick summary of SGW again from the Homotext. Okay, the SGW is talking with eNode Bs. The SGW may also talk with other SGWs. Okay, and you also have SGW talking with the packet gateways. Okay, the third element in the EPC is the packet gateway. Okay, so the packet gateway's functionality is much less than the SGW. Okay, the packet gateway form essentially is like a router. It's a glorified router. Okay, so even companies like Cisco, which produce routers, have now started making packet gateways and GGSNs and so forth. Okay, and what does the packet gateway do? One of the most important functions the packet gateway gives is it gives the IP address to the UE. Okay, so even when you are roaming in a foreign network, okay, and you need to use services in your home network. Okay, remember, it's only when you need to use services in your home network, like for example, if you're working for IBM and you need to access the IBM intranet, which is through your home country, then you will be allocated an IP address from your home network. Okay, so when those packets originating from your UE go through the Singapore network, if you start using the IP addresses from home, previously we used to have problems, and that's why we used to do tunneling. Tunneling is when we put one IP packet inside another IP packet and transmit it, so that we hide the inside packet. Okay, and so essentially the UE is allocated an IP address by the packet gateway. That's one of the important functions it performs. And the other important function is the packet gateway is the one that connects to the external data network. Now, what other function do you think the packet gateway should perform? Remember, whenever you have in the packet switch network, wherever you've got an entity that connects to an external network which is mostly insecure. Remember, the internet is a highly insecure network. You need to have firewalls, and you need to do packet filtering. You've got to make sure that packets going in and out of your network conform to the security policy of the organization. So filtering of packets is also another function that it performs. Now on the next slide we have more details of the functions. So providing UE with an IP address, flow-based charging. Okay, so remember, if all the packets have to go through the PGW before they get to an external network, then the PGW is also a good place to charge users. Okay, on a flow-by-flow basis. So both you could do uplink charging and downlink charging for a particular user. Okay. Remember, in order to charge user, you need to be able to count packets that are going in and out for a particular UE. So the PGW is a guaranteed point through which packets will go in and out. So that's a good place to do charging. And then it connects users to the external packet network. Okay, and it's also used to do packet filtering. So we can avoid spurious packets or packets that don't conform to the security policy of the organization to go through the network. In terms of interfaces, what are the important interfaces for the PGW? Well, it has the S5, S8 interface to the serving gateway, S5 to the home serving gateway, and S8 to a visiting serving gateway. And it also has the SGI network to the external data network. And the PGW is also communicates with the PCRF, which is aspects of quality of service and charging are dealt with PCRF. So, and we're going to talk about that next. And all of that information is transmitted on the GX interface. The next one is the PCRF. Policy and charging rule functions. Okay, so first thing that we have in PCRF is how are we going to charge our users. Okay, and you could have different users being charged differently for the same service. Okay, depending on the quality of service. So for example, you could have a gold class subscriber, whose packets are always given higher priority than a bronze class user, and so they need to be charged higher for providing that priority in the network. And then the next aspect is which services can they use or access. Okay, so sometimes you may have subscribers who are allowed to access certain things and others that are not. Okay, and a simple example I gave you earlier is the fact that somebody might bar international calls on their mobile network, or they could bar roaming. Okay, so all of these are policy related and they'll be kept in this PCRF. And the next aspect is managing policies for user traffic. How do we, when we have millions of users whose packets are coming, okay, do we give priority for certain users over others? Well, it all depends on your subscription. If you're a subscriber who pays, you're a corporate subscriber who's paying more for your service, obviously your packets go through first. Okay, it's just like in an airline. Okay, they usually load the first class passengers first, then the business class, and then the bus class passengers last. Okay, so same sort of idea happens in a mobile network as well. Okay, so a little bit more detail on the next slide. Okay, so we have to have mechanisms for providing quality of service and charging for various data flows. And this term SDF, service data flows, is another nice acronym in the subject. So the PCRF is essentially the entity that decides how different SDFs are going to be treated. So what happens when a UE attaches? Well, remember, when a UE attaching is the process by which it requests a service, and the essentially we might set up, there are different types of bearers. Okay, we might set up a default bearer for a UE, and then we may also set up, you could also have more than one bearer. Okay, so you could maybe have a bearer for your voice call, you could have a separate bearer for your data sessions, and those could be having two different quality of services. So when the PGW goes to the PCRF and says, look, can you give me information about this subscriber, we have the associated with the PCRF is a repository. Okay, and it's called the SPR, again another nice acronym, subscriber profile repository, and from this repository we are able to extract information about a user and how the sort of rules that are associated with providing of service and for charging of this user. Okay, so I'll let you go through what's on slide 63. There's more detail below the slide that explains how the PCRF works. In terms of interfaces, the PCRF has an interface to the packet gateway called the GX interface, and also an interface called the SP interface to the subscriber repository. Now, the SPR could be also located within the HSS, because that will be one place where we have all the subscriber related information. Okay, in terms of a box, this is an Alcatel-Lucent, nothing special. Okay, and then again a summary of PCRF is given in the next slides, showing how the PCRF interacts with both the PGW as well as the SGW. Okay, so sometimes there are situations where we may have millions of user data flowing between from the UE. Remember, the data path is UE, E node B, serving gateway, packet gateway, and out to the internet. Sometimes we may experience congestion. Okay, and if we do experience congestions, we have to start dropping packets. Okay, so whose packets do we drop? The effect of the quality of service that is provided to a user has to be enforced at the PGW as well as the serving gateway. So you have this term here, PMIP. That's where both in the PG gateway as well as the S gateway, we need to have a mechanism by which the policies that are set in PCR are enforced or implemented. And the last network element is the HSS. So the HSS is essentially a database, okay, and I'll be very quick with this one, HSS EIR, okay, and these are a group of databases that store subscriber related information. In some ways it's a new database, but it inherits a lot of the concepts from 3G, the USIM concepts, and the authentication now is based on quartets. Okay, so in GSM, authentication was based on triplets or 3 pieces of information. In 3G, we had 5 pieces of information, which I think are referred to as quintuplets, and now we have gone to quartets, which is 4 pieces of information. Okay, so there's a slight change in the way the HSS works compared to previous ones, and we'll study a little bit more about security. We have a whole lecture or part of a lecture in security a little bit later, and we'll study them more in detail then.